We're going to look at a problem of economics called input-output analysis. The problem was solved by an economist called Leontief, who won the Nobel Prize in Economics for his work. Here we are a few weeks into Math 111, and we can already understand his solution and use it to solve our own problems. Here's the problem. An economy is comprised of different sectors. They are things like manufacturing, transportation, water, electricity, gas, and these sectors must fill the needs of consumers. The consumers want a certain amount of output from each sector. This is called the external demand. In order to produce for consumers, the sectors need some of their own output as well as output from the other sectors. For instance, manufacturing will need electricity and water and possibly some of its own output as well. The amount that sectors need from each other is called the internal demand. And the total output is equal to the internal demand plus the external demand. The external demand is usually a known quantity. It might be based on population or records from a previous year, but it's constant. The problem is to find out how much each sector should produce in order to meet consumer demands. Let's say X is the total output, and that's equal to the internal demand plus the external demand. So what makes this problem complex? Well, it's the internal demand, because the internal demand is not constant, and it depends on the total output. If a sector produces a lot, it will need a lot from the other sectors and from itself for production. And if it produces less, then it will need less. So the internal demand depends on X, the total output. In order to find X, you have to know the internal demand. But to find the internal demand, you have to know X, the total output. So it seems impossible, doesn't it? Let's look at just one sector, say electric. Suppose consumers want $1 million worth of electricity, and to produce $1 worth of electricity, the electric industry needs 10 cents worth of its own product. 10 cents worth of electricity to produce $1 worth of electricity. That gives me this equation. Total output, internal demand, 10 cents for each $1 of output, and X is the total output, plus 1 million. That goes out to consumers. So this goes out to consumers. This goes back to itself, and together that's the total output. Now we can solve this equation algebraically. Problem doesn't seem quite as complex anymore. What we do is combine like terms. I'm going to have X on the left minus 0.1 X, and that's equal to 1 million. When I add like terms, what I'm really doing is factoring out the X. So X is the same as 1X, and 0.10X looks like that, and that's equal to 1 million. So 1 minus 0.1, that's 0.9, equal to 1 million. And to solve for x, I just divide both sides by 0.9. So x is 1,111,111 cents. It's not so important what that number is, but you can see it's more than a million. A million goes out to consumers, and the rest is going back to itself for production. We're going to use the same strategy with many sectors now. Using matrices will really help us out there. We're going to have a matrix equation. X is the total output. A times X is the internal demand. And you can see that depends on X. And D is the external demand, the consumer demand. In the matrix X, we have the total output for each sector in the economy. So X might be a list of 50 values if there's 50 sectors, or 500 values if there's 500 sectors. D also is a list, how much from each sector the consumers want. The matrix A is called the input-output matrix. And we're going to solve this matrix equation in the same way that we did the linear equation just a minute ago. We combine like terms on the left by subtracting AX. So X minus AX, we're left with D. That was the list of consumer demand on the right. Here, in order to combine like terms, instead of 1 times X, remember we have a whole matrix here, it's the identity times X. And then we can factor out the X from both terms. In the linear equation, we divided both sides by that coefficient. Now, because they're matrices, we're going to multiply by the inverse. So I get X by itself if I multiply both sides, right and left, by the inverse of that matrix, and then multiply by D. So there is the solution to the input-output analysis problem for any number of sectors. We're going to look at some small examples to see how to form the input-output matrix A and how to do the calculation to get the solution to this input-output analysis problem.